Hey guys, let's talk about the preparation for standard solutions. We've already said that the standard solutions are the solutions that have a known quantity. Now, a small range of substances are suitable for the direct preparation of accurate standard solutions. Now, these substances that cannot be used for direct preparation of standard solutions include such as sodium hydroxide, potassium hydroxide, and the concentrated sulfuric acid. For what reason? The reason behind is that these substances absorb water vapor from air, and hence they cannot be weighted out precisely without taking extra precautions. And apart from absorbing water vapor from the air, sodium and this potassium hydroxide reacts with the carbon dioxide of the air to form these respective carbonates, potassium carbonate, sodium carbonate, etc. etc. Now let's see more that some solutions are volatile in nature and so are likely to change slowly in concentration during their original use. Now these include the concentrated hydrochloric acid and ammonia. Now, a compound commonly used for the preparation of precisely standard solution is this, which you call hydrous sodium carbonate. It is best prepared from highly pure sodium carbonate. This is achieved by mainly heating this is sodium bicarbonate to constant mass to make sure the compound is fully decomposed. As you can see in the reaction, this is sodium hydrogen carbonate. It leads to this sodium carbonate plus water plus a carbon dioxide gas. Now, the sodium carbonate so formed is suitable. So the sodium carbonate is so formed is suitable for the preparation of standard solutions, and it therefore can be weighted without undergoing any prescribable change in composition. Let's see the volumetric calculations. Data of the calculations of volumetric problems are obtained from the volumetric analysis experiments. Now, for any volumetric analysis problem, at least one standard solution is required. Now, a correctly balanced equation reaction from which moles ratio can be derived is a prerequisite for all these calculations. This is because the mole ratio is in an integral part of the general expressions used for all the volumetric analysis calculations. So, for example, this is one of the formulas that is used, or the general expression that is used in volumetric calculations, that VA MA over VB VB equals to NA upon NB, or VA MA over NA equals to VB MB over NB, whereby VA is equal to volume of acid, MA is equal to molarity of acid, VB is equal to volume of base, MB is equal to molarity of base, NA is equal to number of moles of acid, and the NB is equal to number of moles of base. So that's how you can simply calculate various volumetric questions using that equation. Let us see the applications of volumetric analysis. The first one is that it is used in the preparation of standard solutions, as these standard solutions are prepared by applying the knowledge of volumetric analysis. This volumetric analysis is what is used in these schools knowledge, school knowledge, college and university chemistry laboratories to determine concentration of unknown substances. Now, the titrant, that is the known solution, is added to a known quantity of analyte, that is the unknown solution, and the reaction takes place. Now, knowing the volume of titrate allows one to determine the concentration of unknown substance. The second application that it is used in the agriculture, whereby volumetric analysis technique is used to determine the soil pH. This is important because the pH of a certain soil is found to be extremely low or high. Corrective measures are taken by adding the correct quantity of these agricultural limes or other chemicals to make the soil suitable for the plant growth. Now, the method is also used by these agronomists and the farmers to analyze the kind and the amount of plant nutrient elements present in a particular sample of soil, the knowledge of which helps to determine the soil fertility. The other application that is used in this food and beverage industry, whereby in food and beverage industry, the manufacturers must ensure their products meet certain quality criteria or contain a standard concentration of specific additives. So titration is often used to analyze the products before sale. For example, wine is often affected by its degree of acidity, so it is possible to improve wine production by measuring the acidity during titration. Now, the results of the titration test on wine can suggest if the additional ingredients are necessary to maintain its quality. The acidity of the orange juice, for example, also is easily determined using this standard titration process, whereby in this process, an electrode is added to a solution made up of orange juice and the deionized water. Now, the titrant catalyst then measures the acidity of juice. So basically, manufacturers can use the technique to vary this quantity to satisfy customers or those with the special nutritional needs. The other use it is in the environmental and water safety. We've seen that titration is important in the environmental chemistry, whereby these scientists can use it to analyze the acidic rain and the contaminants in the surface water samples. Environmental studies also usually involve these analysis of precipitation and its response to pollution. So to quantify the degree of contamination in natural rainwater or snow, titration is what is used. The safety of water is based on its chemical ingredients, whereby by analyzing this wastewater, the extent of the contamination and the requirements for the filtering and the cleaning can be determined. So that's all for this session. Obviously, we've talked about calculating volumetric analysis questions, preparation of standard solutions, and the application of these volumetric analysis in real life situations. Thank you.